All right, this is our vocabulary review for the end of Chapter 1 in Geometry Concepts. What we have here are a list of some of our major vocabulary words that we're going to carry with us throughout this year. And so what they've given you is the definition and then an example of that, or I should say the word and then an example of the word. And what I've done is try to add to the definition as we go. So conjecture, what you will need to write down is the product of 4 consecutive numbers plus 1 is always a perfect square. So I wanted you to give an example of a conjecture. You could look throughout lesson 1.2 and find those. But what I look at when I look at our definition of conjecture is it's an unproven statement based on patterns. That's what we said a conjecture was going to be. So we haven't proven anything. We're just going to look for patterns and decide what our guess should be. Point, line, and plane. We can draw a picture of the plane that looks like that piece of paper. The line, which is one-dimensional with the arrowheads, and the point is just the dot. And these are our undefined terms of the chapter. We don't have a way of defining point, line, and plane other than to say that they're undefined. A postulate. One of the examples of a postulate is that through any 2 points, there's exactly 1 line. We've had quite a few. I think we got up to postulate 6 in this chapter. But a postulate is just statements that are accepted without being proven. And then collinear points, they drew a line and they put 3 points on it. So collinear points are just points that lie in the same line. We could have 2 points that are collinear. We could have 5 points that are collinear. The line goes on forever in both directions. We see the arrowheads. And so we could have an infinite number of points on there. What I might recommend doing at this point, ladies and gentlemen, is now that I've been through all 4 of the vocab words, pausing, getting things caught up in writing. And so there will be 4 words per screen. So here we go. Coplanar points, they drew a plane and they put 4 points on there. Coplanar are just points that lie on the same plane. And so like we said, you could have 2, 3, 4, an infinite number, but it's that floor, wall, whatever we want to think about, that 2-dimensional plane. Coplanar lines, they're showing line M, N, and P as being coplanar. And coplanar lines are just lines that lie on the same plane. Segments and endpoints. A segment is just a part of a line. We find segments on a line, but they're called segments because they have a beginning and an end. So A and B are beginning and end, and we call those end points. Ray, AB is a ray with an initial point A. It begins at A and moves towards B. And so what I put on there is the point without the arrow. If we look at the name of this, A does not have the arrow above it. So the point without the arrowhead is the end point of the ray. So I should be able to replicate this ray simply from that definition, the name of it, because I know A has to be the end point and it has to travel over point B. Intersect and intersection. Lines and planes will intersect, and the place that they intersect is what we call the intersection. So they can ask you questions, do they intersect, yes or no, and then they can ask you what the intersection is. And so when they ask you for the intersection, what we know is that lines intersect at a point and planes intersect at a line. And so we've been looking at some of those. That was what you worked on as part of your quiz this last Friday. Coordinates, the coordinate of S is 5. So they have this point on a line and they name that it's at position 5. We think of a number line in that. We also can think of coordinates. It just names a point's position. And it can be one number like we saw in the example, or it can be on a coordinate plane where we have X, Y. And so we've also graphed points with their coordinates, but it just helps us find position. Distance and length of segments, our next two go together. The distance between A and B is 10, and then the length of AB is 10. And so often, once we start talking about length, we have to refer to a segment. So, but when we talk about distance, we're talking about the space between 2 points. But length and distance are the same thing. They are equal as long as we're referring to the same 2 points on the same segment. We know a point is between if it's in the middle or inside the 2 points. So the definition between would be M is between L and N. And so once I hear that, I can start to visualize what the drawing looks like. Congruent segments are just segments that have the same length. So congruent is to have the same measure. We can talk about congruent segments. We can talk about congruent angles. It simply means that they have the same measure. And what we want to look at here, let's see if I can highlight this a little bit. This is what it means. Oh, no, that's going to be too much. I'll kind of point at that. But this notation here means to be congruent. It's the equal sign with kind of a wave over it. But it just tells us that segment AB is the same measure as segment CD. Angle, side, and vertex. An angle is made up of two sides and a vertex. And what we want to remember here is that it is side, angle, side to name an angle. You're going to go from a side to a vertex to an angle. I should change that. Sorry, guys. That should say vertex here. So it's side, vertex, side. Vertex is that corner point. So when you think of an angle being made up of two rays, the end point of each of those rays is your vertex. The measure of an angle in degrees, we would just say the measure of angle A is 45 degrees. So we denote measure by using this little m, so make sure you get that written down. So that m, angle A, is equal to 45 degrees. And when we did our angle activity, our measurement activity, we worked on making sure we had degrees written in there. We just have one last page of definitions. Congruent angles. Congruent angles are angles that have the same measure, and so they're going to show that they're congruent by putting just that arc in each side, each of those. So angle A, B, C, or just angle B is congruent. That equal sign with a wave over it is congruent to angle E. An acute angle is an angle that measures between 0 and 90 degrees. So we just said it's between 0 and 90 degrees. A right angle is an angle that measures, so you see that M there, exactly 90 degrees. An obtuse angle is a measurement between 90 and 180, and so that was kind of what we wrote down in our words, is that it's between 90 and 180 degrees. And then a straight angle, the measure is equal to 180 degrees. That straight angle looks like a straight line, so we know a straight line has an angle measure of 180 degrees. That's it for our vocab for this chapter. So like I said, I hope you were pausing. You can rewind and go back and catch any of those words. But you do need to make sure you get these filled in so that you have those to study before your test. Hopefully also you remembered that your assignment was page 42, numbers 1 through 12, and then page 47, numbers 1 through 7. I have put those pages online at www.lakeshoremath.weebly.com, and you need to look for those under the assignment tab. So you're going to go to the assignment tab to find those if you don't have your book at home.